Okay, so we're recording now. So in the spirit of our future days where we have more to review, how about we do a review now? Does anybody have any questions they'd like to ask? And this could include questions about the textbook, problems from the textbook, for example. Okay. So Santana, who were we looking at? You're muted.
Can you hear me now?
Well, I hear you now, but I'm talking to Santana Ambrujo.
That's me.
Oh, okay. Yeah, I didn't see the yellow square. So who are we looking at?
I was looking at my dog Skeeter because I spilled something. An accident.
Yeah. So who else has a pet they want to show? I do, but she's not in the room. Anybody? Oh, here she is. Look at that. Ask and she's here. Oh, but she's so hard to pick up. Oh, here she is. Oh, whoops. Oh. So here's Fredo. Fredo's 4 months old. She's a Spanish water dog, and she's a demon. Okay, there she goes. And she's joined by Hector and Lily, who are both Portuguese water dogs, and they don't get along because Spain and Portugal, you know how it is. Anybody else? Okay.
My cat
Nobody
just
else.
left, but he left me covered in his hair.
Yeah. Yep, the Porties and the Spanish water dogs don't shed, in theory, but our 3-year-old Porty does shed, so I'm covered in his hair. Yep. So, yeah, wonderful. All dogs are puppies. Young dogs are puppies, and old dogs are puppies. All dogs are puppies. Okay. So nothing to review then? No questions? Okay. Mitchell and Brennan and Jonathan, could you turn on your cameras? You okay with that? Good. Thank you, Mitchell.
I'm sorry, Professor. I'm having camera troubles right now, so if I turn it on, it's not connected. Like, it won't feed the video through. So
Okie
I'm
dokie.
trying to figure it out.
Okay, dokie. Yeah, so set that aside for now, and but you're able to see, right? You see and hear?
Yes, sir.
Good.
And I don't have a camera.
Okay. All right, and that was Jonathan. Thank you. Thank you for the explanation, Jonathan. All right. So moving past review, I'd like to spend a few minutes talking history, because history is included in Chapter 1. So let me share my desktop. And go there and go here. And let's start with, okay. So what I'm showing you is a room full of computers. So these clearly they look like people. In fact, they're largely women. But what are they doing? They are computing. So this is where the term computer comes from. It's those people and they're computing. Therefore, they are computers using calculators. So that's where the word comes from. Now, what they would be working on, they would each have a set of inputs, which they would type into their calculator, and they would each have a planned set of operations. And that was essentially their computer program. That was their algorithm. And maybe they're working on something like ballistics tables for the Army or Navy. That was a heavy duty use of computing before computers. So for instance, if the temperature is something and the humidity is something and the angle of the gun is something and there were 3 pounds of gunpowder in the barrel, how far will the projectile go? And that's what these folks might be computing right now. Right? Now, that was part of a field of called numerical analysis, and this field is the genesis of modern day computers. What they're doing is doing complex math using only addition and subtraction. Maybe they have multiplied. Right? So numerical analysis was the study of doing complex math using only simple operations. By multiple steps, an algorithm, a program, if you will. And from these people here, we shifted forward in time to these are programmers also. But they are programming a computer. The early computers have names like UNIVAC, EDSAC, ENIAC, and notice they each end in AC, and that was to differentiate them from humans. Human computers, the AC stands for automatic computers. So once again, and this is worth noting, digressing a bit, that the whole foundation of computer science rests upon the work of super intelligent, super creative women. And it's really important that they be recognized, the role of women in computer science be recognized, and the role of women in computer science today be cherished and encouraged. In modern times, recent times, the role of women participation of women has gone down, and that's a terrible thing because no single subset of humanity has a monopoly on creativity, a monopoly on intelligence and passion. We need to succeed as a species. We need everyone. We need the best and the brightest, no matter who you are. And that's why we suffer. We lose if most computer programmers are men. Now, the way that we contribute to one of the ways in which we contribute at Carthage to encouraging the participation of females in computer science is it's very simple. It's very simple. You ready? You ready? You all listening? We encourage our male students not to be assholes. Okay? So that actually is right there. Right there is one thing that we males can do to encourage half of our brilliance in our population to join us in the field of computing. Okay, so these folks are programming. Do you see the code? Now, they're using an early computer, in this case, the ENIAC, and these early computers were constructed in a fundamentally different way than all the computers that came after. Data is being stored using different technology, but conceptually the same as today. Data in this computer is stored in something likened to a memory. However, the code is expressed by what wire connects what hole to what other hole. So the instructions that are telling this computer what to do is embedded in the configuration of all these cables that you see. So these women are actually coding, but the code is fundamentally different from the data. The data is in memory, like it is today, but the code is embedded in these wires. And then a person, namely this person, came along. This is John von Neumann, a Hungarian mathematician, came to the US, helped build the atom bomb, helped build the hydrogen bomb, and also came up with a concept called, which we call today, he didn't call it, but he called it the stored program concept, but today we call it more commonly the von Neumann architectures. This is John von Neumann. And his contribution to progress was the idea that instructions should be stored in memory also, just like data. So it is the contribution of John von Neumann that allows, that makes your phone able to do what it does without a whole bunch of little cables. And also keep in mind that those cables couldn't be changed. It was a big deal to change them. So that tells you old computers could only do one program until it was a big deal to remove all the wires and plug them in again. Now Zoom is having a lot of internet connectivity problems today. So if I cut out, you'll need to tell me to repeat whatever it is that you missed me saying, okay? All right, any questions so far?
Wait, so what was the data stored in was the data stored in memory as well before he made his invention or whatever?
Correct. So the data was stored in some type of memory, but the instructions were embedded in what cable was connected to what hole.
Okay.
Okay, any other questions? Okay, so I think you'll get a chance to read about some of this in one of the sections in the book, in chapter 1. All right, speaking of the book, is there any question in the book that's stumping you that you might, that we could go over in class?
I have a question that was kind of in the book, but it was more really in the project.
All right.
So how do we take like a string and then turn that string into a variable?
We're going to do it today.
Okay.
We're going to do it today a whole bunch. But the short answer is getting input is using the function called input. Oh, let me digress for a moment because I love digressing. Let me ask you a question. What color is George Washington's white horse?
White.
Right. So education research says that it's a good thing when instructors share a little bit about their own experiences, their own lives. Not too much, because there's a line where you cross the line, you go to jail. But let me share something from my own youth, and that is when I was very little, my dad used to ask me questions like the one that I just asked you. What color is George Washington's white horse? And what makes that a silly question, kind of silly question, or appropriate for a 4-year-old, is that the answer is embedded in the question. So if, and I'm going to do that, I take particular delight in asking you questions where the answer is embedded in the question. So for example, now we're popping the stack and we're not digressing anymore. Michael asked about input. I might ask you a question. What Python function is used to get input? And the answer is input, right? So that was an example of George Washington's white horse question. So we're going to use input quite a bit today.
Like, how do I take, because I saw in the book, I didn't finish the chapter all the way through, but I got to the point where we were talking about input, and I saw how to take the input and turn it into an integer. Like, how do I take like the word white, if I type in white for the input, how do I make like the string of letters that spell white into a variable that then has a value assigned to it?
We will do that today, but it's very close to the statement or instructions that you're referring to. Let me quick answer that.
Mhm.
So you are asking something like, you saw this. Okay, so you saw something like this. Maybe this was here, maybe this wasn't here.
Mhm.
Okay, so what this did is put out a prompt, hi, and then waited for you to do input. And then the result of input was a string which is converted by this part to a number. So to input a word and keep it a word, it turns out you're always inputting words. But this one is changing the word to a number. So it might have, to get just the word would be to do the exact same thing, but without the int. So hi there. So I shouldn't even put this stuff in there. But so input returns the letters.
Mhm.
So that's the answer to your question. This would take whatever you typed in and put it into a variable on the left-hand side of the equal sign.
Okay. Okay, thank you.
You're quite welcome. Okay. Anybody have any other questions that we can address now?
Wait, can you explain when you would want int versus just input?
Right, that's a great question. If you need to do a calculation, some kind of math, doing math on the returned value of input is an error because you can't do math on a string. Let's demonstrate that because the very next thing that we're going to go into is Replit. So I encourage you to go to your browser. Oh, let me just mention, here is the playlist I sent you by email, the link to the playlist, and you'll see so far section 1 and 2, the class recordings from Tuesday, section 1 and 2. If you're in class section 2, but I'm just so awesome that I can imagine very well, I totally understand if you can't get enough of me, you can also watch section 1's video as well. Right? Now there's also a video already on there for project 2. That's because project 2 sort of operates in motion, and I wanted you to be able to see the motion. But of course, project 2 is not assigned yet. Now, in these videos, I don't know what I just did. Let's see. So this is supposed to be a video. Oh, there it is. Okay. Now you'll notice that if I did it right, they're not here. Okay. So if you enable the closed captions, there is already present well transcribed by a human, all of the words that were spoken. But you have to enable the closed captions in order to see them. Okay? All right. So let's go to Replit. Please log in. And for all of our in-class work, you only need the one Replit. And this is from the previous class, so I'm going to just glance at it to get an idea of what I did and hopefully try to do it again. So last time we used the console. You see that this word here, it says console, as opposed to shell. And I told you that you can use Python in two ways. One is interactive. That's what console does. And the other one is to use the shell, where you'd run programs in general. So console is kind of limited. You can use it like a calculator, but if you wanted to do anything that was at all sophisticated, you wouldn't want to use this here because you'd have to type in the program each and every time. So instead, if you want to write something, anything that's at all sophisticated, and you want to reuse it time and again, you have to put it into a source code file. Namely, the default one is main.py, and the .py suggests that it's a Python file. And the way that you execute a Python program would be using the shell. Let me demonstrate that. So print hello. Okay. Now click over to your shell. Make sure the shell tab is clicked. And notice notice my cursor is an outlined box. That means if I type right now, nothing will happen. You have to click in the black part of the tab, and that your cursor will turn to an opaque block. And now you can type in PYTHON space, and then the name of the file that you want to execute. In this case, main.py. Okay, so now we've actually written a Python program. Let's not call this our first Python program, though. So we've written a Python program and we've executed it. And you know what? We can execute it as many times as we want. Let me interject a shortcut for the shell. You can use the up arrow. So let me add some other statements here. You don't have to repeat this. This is just for demonstration. Okay, so I'm going to use the up arrow. And if I up arrow once, I get the very last thing that I did. And if I up arrow again, I get back to the thing that I did before that. So rather than retyping Python main.py over and over again, you could use your up arrows. Okay, try that, okay? Okie doke. So tell you what, let's go ahead and write an actual program. How about, let's take Michael's cue and say we want to enter a word from the keyboard. So that's using input. And I want to print the word. Now, before I actually run this, when we were in the interactive console, we could have simply said Word and it would print out. Let's try that. So Word, I'm in console tab now, notice. Word equals input. And now it's just sitting there. There's no prompt. So it's just sitting there and it's waiting for me to enter something and hit return. Now in the interactive mode in the console, I could then simply say Word, and that's like printing. So what I have here is exactly what I have here, but let's try it using the shell. Okay, so up arrow. So far it's the same. It's waiting for me to give it input. I hit return and it didn't print anything. So when you type in the name of a variable in the interactive console, you'll see its value. But when you're running Python as a program, you don't. So instead, we have to explicitly print. Okay, let's try that now. No prompt, it's just waiting for me. There. Let's make a nicer program. If you add a string inside the input command, let's see, was there a chat? If there's something in the chat, okay, there's gray, okay. So inside the input, in between the parentheses, please enter, or let me just make it shorter because I'm gonna run out of room. Hey folks, if you want some more room horizontally, you can go over here and the icon is already lit up. So I'm gonna click it again and it gives me more room. If I wanna see what the files are, I can click it, make it go away, reappear, go away. Okay, now I've got more room. Any questions so far? Yeah, go ahead.
How is the shell different from just hitting run?
The hitting run will use the shell as in a very specific subcase.
Okay.
So the shell is just way, way, way more powerful, way more general.
What are the red quotation marks? What are those for?
These,
Yes, those.
well, in one way, they're kind of for making little faces. But no, that's probably not the answer you're looking for. So those are in red. Replit is trying to help us understand our code by color coding part of it. So the word input and the word print are in whatever color that is. Let's call it purple. Let's call it plum, right? Because if something's purple, that's very nice, but if it's plum, it costs more. So let's call it plum. So the words that are in plum are parts of Python. So WORD is not part of Python. It's just a variable name I chose. But INPUT means something specific to Python. So that's what the the plum is for. And the red tells you what's inside a string, a properly formatted string. Now I specified properly formatted because let me show you a badly formatted string. Okay, I lied. Let me show you a differently badly formatted string. Wouldn't it be nice? Okay, so this goes back to something we mentioned on Tuesday, that a string can be enclosed either by single quotes or double quotes. Now, in this case, it's a mistake, and you can see the red turns to black because I tried to use inside of my string a single apostrophe. I'm trying to use the quote mark as an apostrophe, but I can't because I started the string with a single quote. So wouldn't it be nice to be able to use apostrophes as apostrophes, single quotes as apostrophes? Well, yes, you can. Watch what happens to the coloring when I replace the single quotes on the outside with double quotes. So now it all turns red. Does that answer your question?
Yes.
Good, good, good. My pleasure. It was a good question. Personally, I prefer the single quotes, so let me show you and talk about one other way of that would allow you to use single quotes on the outside and on the inside. Okay, so we're back to an error. I want to mark somehow this single quote as not counting towards being part of ending the string. So I'll use this character. Watch. That is the backslash located above your return or enter key. So there are a few characters, not all characters, there are a few characters that you can escape using the backslash, which computer people would call a backslash. We're all so impatient. Computers are so fast, we have to come up with all sorts of abbreviations. So if I use the escape character, this bash, I can use a single quote inside of a string that's surrounded by single quotes. All right, now that's a funny prompt, so let me choose something else. Enter a word. So let's run this program. Remember, you could use the up arrow. Enter a word, and whoops, I began with a semicolon. I don't want to do that just because it'll look weird. So I entered whatever it is that I wanted to enter, and it'll print it out. So I'd like to draw your attention that there's no gap between the D and the L. The D that was the last letter of the prompt, and the L, which is the first letter of my input. So let's go ahead and make it a little bit more pretty. I'll put a colon and a space. And I'm doing this only to make it look more presentable, more professional. Ah, that looks much nicer. Okay. Now does anybody have any questions? Okay, seeing none. When I look down here I'm looking at a second computer that has everybody's faces on it, because here I can only see what I'm doing. Okay. I wonder what I would get if I tried this. Word, a variable, comma, or instead of that, let's do this. The word you entered was, and then a ending quote, and then a comma. Let's try that. For Fortitude. Oh, I'm doing terrible things here. Fortitude. Ah, the word you entered was fortitude. Does anybody see a subtle difference between line 1 and line 2 with respect to spaces? Anybody?
I think you just used a comma for a space on the second one.
Yes. So on line 1, if I wanted an ending space, I had to put it in myself. But when you're using the comma in the print function to print more than one thing at once, the comma causes a space. Okay. There is a very frequently used Python function which calculates the length of something. Now, it's not quite a George Washington's white horse question, not quite. You'll see why. But what do you think you need to use in order to calculate a length?
Len.
Yep, very close. So that's why I said it was not quite. And that would be, let's say, print, where are, and then comma, len word, a variable. Then a string again, letters in word. Let's try that. Okay, so len, remember that, because it shows up again and again and again. We're going to use it frequently in Python. Okay, the next thing I'd like to demonstrate, if there are no questions, let me glance at your faces. Anybody, question? Okay. So if there are no questions, I'm repeating myself, let's move on to something else. How about another word? How about word 2 equals input? How about that? And now I wonder what I would get. Wouldn't it be, I wonder what you could use to add one word to another, like concatenate them, just to add them together. Do you remember? We actually did it on Tuesday. So I want to run the two words together with no spaces. I want to add one to the other. Okay, that is a George Washington's white horse question. How about, anybody remember? No? Here it comes. If you want to add one word to the other, use plus sign. Let's try that. Okay, so there they've just been run together.
Why did that not come as an error?
Because both the left-hand side of the plus sign and the right-hand side of the plus sign were strings. Now, that's a really good question you're asking. Let me run it again, and this time enter numbers. Enter a word, 1, and enter the second word, George. No error. And that goes back to the answer that I provided earlier, in that input always returns strings. So when I entered 1 or 2 here, when I enter 2, that is the letter 2, not the number 2. So the string for 2 can be added to the string for that garbage. Okay. However, let's now introduce a number. So word plus word 2 plus 3. And Michael, what do you think is going to happen?
Error,
That what?
error.
Error, exactly right. Word 1, 3, 5, error. And the error says you can only concatenate strings, not strings and numbers.
So then if we like actually wanted to do like a calculator thing, and it's just like we're gonna add these two numbers, would have to be int input.
Perfect. So let's modify that. And just so we don't get confused, I'll say enter a number. And it'll still be confusing, but please bear with me. And we won't be able to do the length anymore. So let's do int. And now we can add one number to another with, all right, let's see, where did I go wrong? Line 4. Oh, I missed the parenthesis. Does everybody see where I missed it? Can anyone tell me where I missed the parenthesis?
Line 3.
Yes, on line 3, because I have an open and then an open, and I have a close. I'm missing another close. So the number of open parentheses must match the number of closed parentheses. 3 and 6, and the answer is 12. 3 plus 3 plus 6. Okay, how's everybody doing? I'm taking it in very small bite-sized chunks. Okie doke. Anybody? Good. So take a look at what we've done so far. We've written, in this case, 4, that's me again. Here, we've written 2 lines of code. I always get my fingers wrong. So anyway, I just won't show fingers. We've written 4 lines of code, right? And maybe we had written many more lines of code, but what I want to draw your attention to is line 1 happened, then line 2, then line 3, then line 4. And every time we run this program, the statements execute in the same order every single time. So there's got to be more to Python than this, because if we can't vary which instructions get executed in different places of the program, that's a very, very limiting programming language. In other words, if it's only sequential with no ways to veer one way or take an alternate choice another way. There's no way to make decisions. So there must be some way. If only there was some way. And the way that you do that, let's introduce another part of the language, if we may. Let's go here. So if some test is true, then do some code. Now, clearly, this is not Python. But the idea is, this is expressing in English, and now I'll put it in picture form. So this is the code that I've executed so far. And I'm coming to some type of decision point. This is called a flow chart. And decisions are just by convention drawn with diamonds. So this is some test. And the test evaluates to either true or false. So if some test, if it's true, do some code. And then continue on. And if the test is not true, skip that code. Okay. So let's try this in our program. Anybody have any questions about the picture? Okay. So I'll make some modifications here. Enter a number, the number you entered. Okay, so I'll pause for a moment if you want to make changes to your own code. Okay, let's pick that up again. Okay, so tell you what, if, and here's how you write some kind of test. The test needs to evaluate to true or false. So is something the same as something else? Is something more than something else? Is it less than or equal to something else? So how about if num is greater than 20, colon. And now watch what happens when I hit the enter key. It indented for me automatically. The indenting in Python is critical. Absolutely critical. Indentation is not just for good looks, it's actually part of the language. And I'm going to hit enter. It indents automatically, but now I'm going to hit the backspace or delete on the Mac. Okay. I'm going to do another, I'll skip a line just to make it pretty. After the if statement. That's just to tell us that we've gotten beyond the if statement. Okay. Let's try that. Okay, so 99, line 3 says, if 99 is bigger than 20, yes or no? The answer is yes. So we do the what's nested under the if statement. And by nested, I mean what's indented under the if statement. Now, how about what happens when it's false, when num is 20 or less? How about 8? So you see how the line 4 was skipped. Let's go back to the picture here and modify the picture a little. There, okay. So here I'm going to write in is if num is greater than 20. And if true, do the print. Oh, and pardon me, I should have written false here. So can you see how in this picture, it maps identically, it maps directly over to the code. So the code that comes before, actually I'm going to use this fancy new tool here that I didn't know about. Here's the code that comes before, that's cool, it disappears. And then here's the decision, here's a test, is num greater than 20? If it's true, we'll do the print and then continue on. This is when we get here because the indenting has stopped. But if it's false, we skip doing that print. Let's take a look at the code again. Okay. Questions?
How do you test for words?
What kind of test would you like to do?
Like how do I test if num is bottle?
Okay. Since I already have this going here, I'll just write it out. So it'd be, whoops, something like, you might have something like input, some prompt, and you might have if word double equals. That's a logical operator. That's a test. Is this the same as that? If word equals bottle, colon, and then what to do if the word does equal bottle.
How do you do something like with like two ifs need to happen?
Let me repeat back to you in different words. Are you asking if the word equals bottle and the temperature is greater than 100 degrees?
Yeah, something similar like that.
Okay, so and that's an excellent question, Michael. You're feeding me all the straight lines, right? Because we are going to do that part of this lecture too, and you have to use it in your project. So let's say you also had temperature equals 68. So you would write if word, here's one part, and on purpose I mixed using single and double quotes. See over here I used the double, but over here I used the single. And I did that on purpose to emphasize that it's okay. Let me continue on. So, if you wanted to test the conjunction, what's the word we use in English for a conjunction? Anybody?
And.
That's right. So guess what it is in Python?
And.
Mm-hmm. Now, I'm sure that's hard to read, and we'll repeat this example or something like this again and again in this lecture. But what this says is, if word, which is a variable, has the value bottle, and temperature has a value greater than 90, then the colon, and then there would be the lines of code to do.
So like in English, would the colon be like then?
Yes, perfect. You're doing a great job for you, Michael. Keep it up. Okay. Now, before we move away from this into a more complicated form of if, let's look at how and works. And I'm going to draw something for you called a truth table. So this is the and operator. And an and, you say A and B. So there's a left hand of the and there's a right hand of the and. So what I'm drawing here is this could be the left hand, and down this way could be the right hand. Either way, it doesn't matter. So true, false, and true, false. So you've got a left hand and a right hand, and the left hand can be true or false, and the right hand can be true or false. So that means we have 4 possible choices. So if both sides of the and operator were false, in other words, this box here, what would you think the result of the whole thing would be? If false and false.
False.
Good, very good. All right, now how about if the left hand is true, so true and false. What do you think the result is?
False.
So false.
Exactly, perfect. Or what about the flip side? If false and true would also be false. So the only way to get a true out of an and is if both the left-hand side and the right-hand side were both themselves true. Okay. There's also or. And the way to express an or in Python is literally the letters OR. So let's do the same thing, another truth table. There's a left-hand side to the or and a right-hand side to the or. And both of those sides can be true or false themselves. So in total, there are 4 potential outcomes. So how about this one? If true or true, what do you think? That's this box. True or true
True.
evaluates to true. How about false or false?
False.
Good. And how about true or false?
True.
Got it. Yeah. And then false or true. So compare. There's kind of a nice symmetry there. So 3 Fs on the and 3 Ts on the or. Okay. Does anybody have any questions?
Could you just explain the or a little bit more in depth? I'm just a little confused at like the reason for why it would be true for if it's true or false.
Okay. How about this? I'll write it in English. Okay. So if they have chocolate or butterscotch, buy ice cream. So let's take chocolate. Do they have chocolate? Chocolate. And do they have butterscotch? Yeah. At one time I liked it. So let's say this is false and this is false. So let's look up on the or truth table, which is right above. Let me make it a little smaller so we can see everything. Good. So if they have chocolate is false and they have butterscotch is false, then we're looking at this box. So in this case, you would not buy ice cream. Do we agree? Okay. Good. So Trey, we agree. Well, how about let's try, and I'll even add a little detail here. No, yeah, good. All right. So I'm going to change this one to true. And I think we can already see that we will buy ice cream, but there's a detail I want to point out. So let's work this out. So if they have chocolate, so I'm evaluating the left-hand side of the or. Do they have chocolate? It's false. So I'll continue on. I better evaluate the right-hand side of the and. Do they have butterscotch? And yes, they do. So I'll buy ice cream. So the fact that we're going to buy ice cream because one of these is true is kind of clear, but the implicit part here is I checked the right-hand side of the or only because the left-hand side was false. Let me look at the flip side here. I'm going to change that to false and true. Oh, yeah, that's exactly what I just erased. I'm sorry. Let me change that to true and false. So now, if they have chocolate, so I'm evaluating the left-hand side of the or. If they have chocolate, that's true. Well, I don't even have to check butterscotch. I'm going to buy ice cream, whether they have butterscotch or not. So I don't even have to check. So that's a little bit more information about how or works. Does that help, Trey?
Yeah, it does. Thank you.
Good. All right. Okay, so let's look at a expanded form of the if. And so, whoops, that's the wrong tool. If some test like we had before, then do this, otherwise Only if the test is false, do that. So let's go look at this picture up here again. And the if statement we learned so far says, if the test is true, do this. Otherwise, skip it. But now we're looking at something slightly different. And that is, if the test is true, do this. Otherwise, there's a different set of code to do. It's do one or the other. Notice you can't do both. So if the picture looks different, here's your code coming in. There's your test. And one side is if you're true. There's some code to do. And on the other side, whoops, no, that's just fine. False. There's some code to do. Do this, or otherwise, do this, otherwise, do that. And this is another test. All right. Any questions about this formulation of the if statement? About the concept, because we haven't looked at the actual code yet. Let's take a look at the code. So if the number is greater than 20, do this. De-indent, else, colon, okay, so one path through the if will be taken. Can't do both, one or the other. So that single test on line 3 governs whether or not we execute line 4 or line 6. Okay, let's try that. 5. Okay, that's not too big. Or, let's try. So in the first time, when I entered 5, the test failed. It was a false, because 5 is not greater than 20. So we execute the else portion, which is line 6. But in the case of 99, the test succeeds. 99 is true statement. 99 is greater than 20, so we execute line 4. Okay. Questions?
I have one question real quick.
Excellent. Go ahead, Santana.
So if you have a number that is greater than 20, but you want a different text to show up instead of the one that's a big number, is there a way to make that one separate from the rest without having both show up?
Can you give me an example?
If you were put if you put in 100 instead of 21 or something, if it was specifically the number 100, it would put out a different text than just that's a big number.
Perfect. And you've set me up for the very next thing to talk about.
Oh, okay, perfect.
Okay. Now, before we move on to the very next thing to talk about, do we have any other questions?
What if you have 3 different if things to check? If it's
That's the very next thing to talk about.
okay.
Perfect. You're all on the same wavelength. I love it. Okay, so now combine what Asher said and combine what Santana said, and then let's look at a new, and at one more variation of the if statement. Let's head down here. So let's say if, and I'm going to do this in English, if test one, then do this. Otherwise, if test two, I shouldn't have put in those. Then do that. And notice I'm doing vertical because it's a different set of code. Otherwise, let's put in more of them. Let's put in 4 different paths. We can put in as many as we want. Otherwise, if test 3, do this, then, and if none of them, I'm getting very messy, I'm sorry. My hand's getting tired from a full day. If none of them do this code, then that. Okay, so this is, we've got 4 paths. I gotta hold down my pinky. We've got 4 potential paths through this code. If test 1 is true, we'll do this block. Otherwise, only if test 1 is false will we test test 2. We'll do test 2. So if that's true, we'll do this block. But only if both of those are false will we try test 3. And if test 3 is true, we'll do this one. And then if none of them were true at all, we'll try that. We'll do that one. Okay? Now this picture is going to look really interesting. It's going to look something like this. Here's the code that comes before, and here's test 1, T1, and if true, do the lines of code and continue on. This is false. Going to test 2, and if that's true, do the lines of code. Notice I'm carrying forward the horizontal lines and the vertical lines. That doesn't really matter. Okay, if that's false, only if that is also false, try test 3. If that's true, try the diagonal lines. And only if that's false, we'll go ahead and do the squiggly lines of code. Okay, now that we've seen the picture, let's take a look at the code because the picture is getting pretty complicated. Let's take a look at the code. So tell you what, if the number is greater than 100, that is a really big number. Now here comes the way to do else if. It's shortened to elif. Num is greater than 50. Let's put in some new text. Elif and else. Okay. So try to work this out. Suppose you entered 4 48. At line 3, 48 will be compared to line 100. Line 3, 48 will be compared to 100, and the test will fail because 43 is not bigger than 100. So the next thing to be executed is line 5. Line 4 is skipped. Let's try line 5. Is 43 greater than 50? No. So we'll skip line 6 and do then line 7. Is 43 greater than 10? True. So we'll print line 8. And we only get one choice through all of these paths of code. We only get to go down one path. So we skip line 8 and we skip line 9. And the next line to execute is line 12. Okay, so let's try that. 43. Meh. Because it's greater than 10, but less than 50. Okay. Now I'm going to do something here. I want to show you an error. That's not a Python error, but it's a logical error. I'm going to reverse these two. Okay, let's try 43 and see if that works. Line 3 fails because 43 isn't greater than 100. And line 5 is tested then. Line 5, 43 greater than 10, it prints small. And that's actually the output that we wanted. So everything's great, right? Is the code still perfect? No. There's a bug here, a logical bug. Not a Python bug, but a way that you thought about the problem. Let's try the number 60. Now our intent was that we print that's fairly big. But remember, the first path through the code that succeeds is the only one that's going to be executed. So even though what we wanted to do was that's fairly big, line 5's test will also succeed and it is checked first. So instead of getting that's fairly big, we'll get meh. Okay? So when the lesson here is that when stringing together, if, elif, 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 as many times as elif as you need, you have to be careful about the order. Okay, so questions? So for Michael, literally the light just went on. So ordinarily we'd call that, oh, he just got an epiphany, but in this case, his lights actually did go on. Oh, I'm sorry, Mitchell. Well, the letters are so tiny. Yes, Mitchell. I was talking about Mitchell. Anybody have questions?
So how would we get the code to state yawn?
If none of the other tests fail, none of the other tests succeeded. So here, let's go, let's enter -10. Yawn. So it tried line 3, fail. Tried line 5, fail. Tried line 7, fail. All right, if you failed all the others, you're going to do that.
I got a question.
I would love to hear it.
Would 10 net you a yawn?
Yes, it would, because
Okay.
this says specifically greater than 10. So let's try that, make sure, 10, yawn.
Okay,
Okay.
just making sure I wasn't tripping up on something.
Good, 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 good. Now, the syntax for greater than or equal to is, I'll type it here in this window, greater than or equal to is that syntax. So the greater than sign followed immediately with no spaces by the equal sign is greater than or equal to, just like less than or equal to.
How do you just flat out check if something is not something?
Ah, you just asked me a George Washington's white horse question.
Oh.
The way is not.
So
What
like,
do you
would it
think
be
of that?
like, if not cheeseburger, like, would it be like that then?
Yep.
Okay.
And in the in-class, forgive me for sticking a part of my body into another part of my body while on camera, but part of the in-class exercise, if we go to the GitHub page, which is here, I'm showing the progress. By the way, if you want to know what we did on a certain day, you can look here on progress. So this is our GitHub page. And here is an exercise for in class, which you're actually able to do now. So here's what I'd like you to do. Enter two integers. They'll be age 1 and age 2. And then use these if statements with and or, and in the case of the last case, it's actually a little bit more complicated. So if both ages are 16 or greater. Now, the word both there sounds like I'm using what?
And
And, right. And if either, what does that sound like?
Or.
Or, right. Okay, so do you think you could take on this program and do it at your desks where you are? We've got 17 minutes. And it's okay if you can't, we'll just pick it up next time.
Really quick question about if.
Mm-hmm.
Is it possible to do like an if that's been indented inside of an if?
Yes, it is. That's called a nested if.
Okay.
Okay.
And then like once all the indented ifs are finished, it'll just go to whatever's next then?
Yeah, whenever you stop indenting,
Mhm.
that's the end of what's been nested under that if statement.
Okay.
So indentation, as I mentioned, is not just to make your code look nice. Indentation is actually part of the programming language itself. Okay. Now, if you're going to work on this, you could either create a new file. Actually, I haven't demonstrated how to create another file. Why don't I try that? So forgive me. So over here, you see the one that says files? Click on that. And the second icon here that says add file, see that? And let's call this ages.py. And you can add your code here. Now in the shell, instead of running, okay, you would have to run Python ages.py instead of main.py.
If you were to up arrow, then would it go to the ages py?
Yes, and if you up arrow a second time, for some reason it's not letting me. I assume that's because it's a REPL and not a real shell. I think maybe, I'm guessing I can't go up arrow more because it's been a long time since I used REPL. I've been talking to you a long time. On a real Linux computer, I could go up arrow, up arrow, up arrow as much as I want. Yeah, okay, that must be what it is. And by the way, given today's material, you have what you need to do the first project. So let's give a due date to that first project. So not Tuesday, but the Tuesday after. Right? So what is it? 13 days, 12 days from now? Something like that? So not this coming Tuesday, but it'll be due the Tuesday next.
Can you display the instructions again for the?
Oh yeah, of
Yeah.
course I can. Where are they? Yeah, there they are. And so the last one is more complicated than the others.
For the last one, I think I've heard about this. Is it nor or is it and or?
Well, there's several different ways of doing it, but using only and an or, it's possible. So, but here's the hint: use parentheses.
Excuse me. I'm not sure if I did something wrong, but when I was making the new document, I was starting on it. I just realized that like it's not saying that it's Python. It's just like saying it's a normal file. So like,
Oh, did the file name end in .py?
oh, that's probably why. Thanks.
Okay. Okay, we've only got a few minutes left. If you'd like to depart, that's okay. I will stay for another few minutes if you have questions for me.
Thank you.
It was a pleasure.
Thank
Have a
you.
good day.
See you Tuesday.
See you Tuesday. Any
Bye-bye.
questions? Email me in the meantime.
Thank you.
Thank you.
Thank you. Bye-bye.
I have one question.
I'd love to answer it.
So I'm trying to run the command, but it keeps saying bash ages.py command not found.
Okay, have you tried a python space ages.py? So you need the word Python in there first. Can you see that, Jonathan?
Okay, I'll try it. Hold on. I thought I did it.
Yeah, let me try it if I just say ages.py and we'll see if I get that what you said. It says bash. See, that's the problem. It says the same error message that you read to me.
I scrolled through. I misspelled Python. That's why it wasn't working.
Yeah.
Alrighty, so I figured it out. I was thinking of an XOR. So how do you put XOR into Python?
That's interesting. I gotta try to remember. I think there's symbols for it, but not a word. Let's see.
The way I remember XOR is,
Yeah. So I was correct. The caret or hat is XOR operator.
Okay.
It's the upward facing tick above the letter 6 on the 6 key.
Alrighty. Thank you.
You're welcome.
It's working. Thank you.
Good. Thank you, Jonathan. Thank you for letting me know. We'll see you, everybody.
Actually, I have one quick question.
Okay, I'm glad. I was just about to click the end.
Sorry. This is kind of, I guess, a little advanced. Would it be possible to do this in ternary? Or probably just like
ternary? What do you mean?
Like instead of all the if statements for the in-class exercise, could you just reduce it down to like ternary with print statements? Or ternary?
Well, there is in programming languages this concept of a ternary operator.
Yeah.
Are you familiar with a different programming language?
Yeah.
Which one?
Mostly like Go.
Okay.
Yeah. I don't know what it's called in Python.
There is a ternary operator, but it is not pretty.
Got it.
But also, notice I've used the words ternary operator.
Mm-hmm.
So so there's a limitation on that in that with the if and the elif, et cetera, you can have a number of statements, not just one.
Okay.
But the ternary operator in Python is really an operator.
Mm-hmm.
So you can only have a single expression as the if and the else.
Okay. Okay. Thank you so much.
You're welcome. Chad, are you talking to me or somebody else? Okay, Chad, are you talking to me?
I was talking to someone else, but I was going to ask you, my parentheses button doesn't work on my computer, so I got to get a new one, I guess. Do you think an iPad would work for coding? Or is that going to...
Actually, it would be really hard. It doesn't come built in, certainly, but there is an app you can get, you know, like Apple says, there's an app for that.
Yeah, right.
You can actually code on an iPad, but it's not easy.
Yeah, I was thinking I really need to get a new computer because the W button or something doesn't work too. So yeah, I was struggling to try to follow you without parentheses. And the same button is the one parentheses, which is one lash. So that button isn't working for me. Okay, I just was curious your opinion on using an
Here's a
iPad.
suggestion though. If you can find a parenthesis online, you can copy and paste it.
Yeah, I tried that and then it wouldn't paste in the program. It says something else.
Okay.
Yeah, I'll have to find a solution. And thank you. I think that's it.
Okay.
Oh.
Less expensive than a new laptop is just an outboard keyboard, an external keyboard.
Yeah, that would kind of be a quick solution too. If I buy one cheap. And the last thing I was going to say, let me just write keyboard separate. That question you had up at the end of class, are we going to go over that like first thing next class?
Yes.
Okay, so I can work on that. Thank you so much. Enjoy your day. Have a great night.
Okay, thanks. Bye-bye.
Yeah.
Santana, do you have a question?
I've been typing the code right now and I'm starting to get a little confused on the last bit because I think I've got it working so far. Let me just that right there. So I have it working. I think that if it's 16, it'll say if both can drive, and that if it's 25 or more, at least one can. Oh, I didn't put that one there, did I? Oh no, I only put that. Okay. I meant to for the 25th one to put the wrong prompt, but then I also have the if both of them. I think if it's the and with if num and num and num2 are. Oh crap! Did I put it? Okay.
Okay.
I think I'm getting it, but I'm still confused on the if exactly one age is 25 or greater.
Okay, I'm going to make some hand signals.
Okay.
Okay, so imagine an and, and then there's a left-hand side and a right-hand side. So here comes your hint, right? And remember to use parentheses. So if one is like this, or, see, is it?
I get
That's
you.
my hint.
Okay. I'll see if I can try and figure this out. It's more fun than I thought it'd be, at least.
Oh, good. I'm glad. Have a great weekend.
Yeah, you have a great weekend too. Adios.
Bye-bye.